For number 17, using the fundamental theorem of calculus, number 2, what I'm going to do is just substitute this x in, and I'm going to say that f of x is equal to the integral of g of x dx. Well, if I derive both sides, you basically have this. The question asks which of the following could be the graph of y equals g of x. Well, if g of x is equal to the derivative, we're basically looking for the slope of the tangent line. And since this graph is a linear graph, it's a constant rate of change. The slope here, you could say that you could pretend that this graph is 1/2 x or something. Well, if you derive that, you would just have y equals 1/2. This is a constant. This should be a straight horizontal line. Okay, and since it's positive, this line's got to be in the positive quadrant. That's the difference between A and B. For number 18, they want you to evaluate this expression. Well, since this setup is basically means derivative, what they're asking you to do is basically they're saying that y is equal to ln x. The function is ln x. They want you to find the derivative of the function ln of x at the x value of 4. Since we know the derivative of ln x is 1 over x, I'm essentially just going to do 1 over 4. Your answer is choice B. For number 19, they want you to find where does this graph have a tangent line with a slope of 1/2. So what I'm going to do is I am going to derive this using the quotient rule, x plus 2 times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Simplifying that, I have x plus 2 minus x all over, you can expand this, it doesn't really matter. You have f prime of x equals 2 over x squared plus 4 of x plus 4. To find where the slope is 1/2, what I'm going to do is I am going to set this equal to 1/2. And cross multiply, I get 4 equals x squared plus 4x plus 4. Subtracting 4, you have 0 equals x squared plus 4x plus 4. These essentially just kind of cancel out. Solving this equation, you have x times x plus 4. You're going to set both of these equal to 0. X plus 4 equals 0. Minus 4 minus 4, x equals -4. What this means is that that's the x value of one point, and this is the x value of the other point. I would go on and then plug this into the original to find your y value. But in this case, it looks like those are the choice C is the only one that has these x values. For number 20, there may or may not be some type of shortcut for this problem, but what I'm going to do is I'm just going to think outside the box, and I am just going to find the inverse, since it says that G is the inverse of F. Cube root both sides, you have this, 2y plus 1, subtract 1. You have cube root of x minus 1 equals 2y. So what I'm going to do is divide by 2, and then divide this side by 2. It's basically multiplying it by 1/2. So my inverse, my f inverse, is equal to g of x. So I have 1/2 cube root of x minus 1. To find the derivative, you can use the product rule if you wanted to, but that'd be unnecessary because basically what you're doing is you're just kind of pulling 1/2 out, and then you're just deriving this expression. Okay, so the derivative of x to the 1/3 is 1/3 x to the -2/3. The derivative of 1 is 0, right? So you have 1/6 x to the -2/3. So they want you to evaluate the derivative at 1. So long story short, you just get 1/6, and that is choice D.